In this session, we will continue with the last part of continuous probability distributions. Namely, we will talk about the normal distribution. It is also known as the Gaussian distribution or bell curve approach. It's quite popular with the students as well, of course. Usually your lecture grades fit into this distribution and many other things, because probability distributions of many variables can be fit into this Gaussian or bell curve distribution under special conditions. Again, this has two parameters, this distribution, and this is its the population average. But here you see the mu, and this is sigma square, corresponds to variance of the distribution. As you see, if the variance of the distribution is small, you have a sharp distribution, sharper. So this corresponds to its shape, defining its shape, how it is spread around the mean. And this one is the location measure of your distribution. Where is the middle point is located? That's the idea. If it is -2, for example, the most accumulated part is around -2, and this is again its shape parameter. That's it. So for same population mean, same center, if we focus on this one is the sharpest one because it's the smallest. It has the smallest deviation and the smallest variance, and the next one is a bit more pressed down, and the last one is very spread because it has a very high variance with respect to the former ones. Okay, if we look at how we have this distribution, how we have our fx here, this is our x and fx. We're trying to calculate the area under this curve, right? This is what we're dealing with, and we need to have its function. This is its function as given in the textbook. It is sigma times square root of 2p times e to the power x minus mu square over 2 sigma square, where your x is going from minus infinity to infinity. That's it. So we're talking about a curve like this. Okay, the original one is like this. This is called your ordinate value, the ordinate value, namely the how your mass of population is gathered around that part. So it can be either here or either here or either here. Okay, so many, you see, so many of them are gathered here, or so few are gathered here, whatever. Okay, so and this these are your constants. Your p is approximately 3.1415. You can take it like this. It's your p value, and your e is again something close to 2.71. This is your log base, logarithmic base, and these are your constants, right? Constants, where you have them, this one, this one, this one. These are your constants, and mu corresponds to the center of distribution, and this is your standard deviation. Okay, this is also your population average as well. Population average as well. And these are your parameters. Parameters of your normal distribution. And of course, your sigma is here. The sigma is also, it defines its shape, right? It can either be like this, or like this maybe, okay, or maybe like this, whatever, okay. So it all depends on your sigma. So you can this is also your shape shape parameter of your distribution. That's it. As you see, standard distribution is a symmetric distribution around the mean. You see, if you have a line here and you put this together, two sides together, it's just a mirror image of the distribution from the left or right hand side. See, it's the mirror image, okay? If you look from both sides, it's the mirror image. So it's a symmetric distribution around the mean. These are the properties of your normal distribution. And if you want to make the how many of your population is represented here, mu minus plus sigma corresponds to or covers 68%, approximately 68% of the population here. You don't need to memorize them, but you need to have an idea, all right? So mu minus plus 2 sigma covers 95% of your population, and mu minus plus 3 sigma spread covers 99% of your population. You can look at this issue in the other side, like the other side of the coin. If you want to represent 50% of the population, then you need to have mu minus plus this much of sigma spread. Okay, we're just looking at this issue in another way. And if you want to represent 90% of the population, then you need to have, these are the most popular numbers or thresholds that we will be dealing with. And this much of spread is required, standard deviation is required to represent 90%. And if you want to talk about 95% of the population, your mu should be spread like this, 1.96 sigma spread. Okay, this one is 1, better. And finally, if you want to represent 99% of the population, you need 2.575 sigma spread plus, and minus spread from the mean. And the idea is the distance from the mean can be depicted by the standard deviation, okay? The distance from the mean is depicted by the sigma, okay? That's the idea about the property of normal distribution. If your mu z is about where your position is located with respect to the mu center of the population. This is where you are located here, and z is where you are positioned. And when when your z is 0 and sigma z square is 1, this is one particular case. If you have a distribution like this, where its mean is 0 and its variance is 1, of course its standard deviation is also 1, this has a special name and special calculation method, which is pretty neat. It is called the standard normal distribution. Okay, it is called standard normal distribution. That's the idea. So in this sense, you can find your transform any type of your position here and transform them into standard normal distribution to make calculations easier for you, because so that you can make your calculations much more easier, because the Fz here, the area under the curve, can be calculated with this function in this sense, because what you have here, okay, you will put here, for example, 0, and you will put here 1, for example, okay, it will be then your function will be reduced to this one, and it will be much more convenient to calculate the area under the curve this time. And not surprisingly, if you have a structure like this, okay, it's symmetrical around the mean, and the area under this curve will be, total of this one will be 1. This is the area under this curve, and it's equally split on both sides here, like 50% is right here, and the remaining 50% is here on the left hand side. That's it. So when you're trying to calculate the area below these curves on the standard normal distribution here, where is your standard normal distribution here? Can you see it right here? Ah, we have it, right? This one, this nice one. The red one is our standard normal distribution. And for calculations for this purpose, we can have we can use the table for the sake of this, and you see, no need to take the integral and each time to and calculate the area under the curve. We have a very convenient table for this purpose. Now let's take a look at how we can use this table, or how can we make these calculations here. I mean, let's make some exercises with our standard distribution table together. These are the examples taken from our textbook. Okay. Let's start with the first one, where your z is 1.5. So I'm curious about the probability of z within that range. Okay, means that talking about, always draw this. Okay, I mean, don't just okay, don't skip this step. Okay, it will help you a lot. Always draw this and try to figure out where you're located and what kind of area you're trying to calculate here. That will reduce the amount of mistakes you will do, simple mistakes that you might encounter while making your calculations. This is the area I'm curious about right here. So, and look at me now, and just look at this part, minus 1.05 here. If I want to calculate the area under this curve here, would that be equal to this one? Minus 105 with respect to, okay, this one. Are they equal? Of course, yes, right? Because it comes from the definition that it is the, what's going on? It is the, see, it is the mirror symmetric within the two sides right here. So if we take a look at this particular number here, 1.05, let's go to our very convenient table here. You have this in your textbooks as well, or you can find it on the internet. There are many of those standard normal distribution calculation tables, which makes life happier for us. So as you see, 1.05, right? You come from here, tick, 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 tick. Okay, I'm here. We're coming from here, and okay, this is what I'm looking for here. 0.3531. All right. So it means that my probability equals, okay, 0.3531. Like, okay, 31.31% is the area under this particular curve, right? Under this particular curve. This curve. Under this curve is like this. All right. So this is how we use the table, and let's continue with a few more examples to make things sound more clear here. Another example, what is the probability of having z more than 1.1? Okay, so please do not hesitate to take this extra step and draw. Okay, now what I'm being asked is, what is the probability of this one right here, right? Okay, area. Now the thing is, the probability of this one should be z minus 1 should be, this is 0.5, right? This is 0.5, so that would be 0.5 minus probability of 0 z 1.1 minus this one, because my table only calculates up to this point. Okay, now let me take a look at what is 1.1 here. Where does my 1.1 corresponds to? Okay, it's right here, 1.1 exactly, and it is this one. Okay, 0.3643. 0.3643. 0.3643, and the result will be 0.1357. It is like 13% right here. This is what I'm looking for, and this is the area or probability exactly under which curve? This curve, this particular segment of this curve. All right, let's continue with another example together. The probability of being within this range. All right, don't rush. Please don't rush and draw this in order to minimize your mistakes. All right, this is your 0.5 and this is your 1.27. All right, what I'm being asked is, what is these areas under those two curves? It means that I need to add them up, right? If you call this one A1, area 1, and if you call this one area 2, I need to add them up, right? For this one, this is your A1 up to this point, up to 0 here. This is our A1, and from 0 to 1.27 would be your A2 area. Okay, so what are their corresponding numbers here for 0.5 and 0.27? For 0.5, it is pretty obvious right here. It is 0.1915. Okay, 0.1915 plus the blue one would be what it is 1.27, right? 1.27. All right, it is 0.3980. 0.3980 is right here, and your result will be, total area will be this much, and it corresponds to the probability of 59% or something. All right, let's just solve another example here, again taken from your textbook. Now find the z, this time a reverse question. Find the z where the area or the probability from z to z is 0.95. Probability of minus z2 plus z is 0. Okay, this is a rather interesting question here. Another type. So it means that we will have a particular z here and minus z here, and from this part to this part the area should be 0.95. But since I have the symmetry property, this part will be exactly the half of the total part, and the right hand side and left hand side will be equal. So when I divide this by 2, I will get this part exactly 0.475, and this part 47.5 again. Okay, so now I need to find the value for this. Probability from something to something should be this one. So it means that I'm curious about this value, 0.475. Now 0.475 probability here. Do I have it within this table? This is what I'm looking for now. 0.47526. Yeah, right here. All right, I found it. Okay, you see it is located right here. And what is the value for this one? This time you go this way and this way. It is 1.96. So I can comfortably write here from voila, from minus 1.96 to 1.96 and 96, and this is the Z value I'm looking for. That's right, that's the other type of question that can be asked to you. And let's solve another example which has some transformation to the standard normal distribution here for easing the calculations, and everything will be much more clear for you, hopefully. And your x variable shows normal distribution with your average of 10, and the variance is 4. That's right, that's your distribution. That's it. So you have something like this, and your sigma square is 4, where your sigma is 2, whatever. Okay, this is your distribution. And the question is, what is the probability of your x being within this range? All right. I mean, it means that this one is 11, and this one is 13.6, and I'm being asked to calculate the area under this curve, right? Please draw this so that you won't make any simple mistakes. But before we do this calculation, let's go ahead and make this transformation, all right? Together. Make this transformation, please, together. All right, that's it. So let's do this together. So let's call this Z1 and let's call this Z2. Your Z1 is x minus mu over standard deviation, which is namely 11. This is coming from your question, right? 11 minus, this is coming from your population over standard deviation is 2. And this would give you what? 0.5. And your Z2 is what? So it is x2. Let's say that this is x1 and x2. Okay. x2 minus mu over sigma, which is namely 13.6 minus 10 over 2, which is 1.8. Now I need to have two areas here, right? Or two probabilities. I'm trying to figure out from Z1 to Z2. So I need to calculate this Z2 area first because it's larger. Then subtract this Z1 area from this Z2 area. Can you see this? So this is your A2 and this is your A1. So area under this curve, the green area would be what? Your answer or your probability would be A2 minus A1 particularly. Let me just use the correct colors for you to understand. A2 minus A1. Okay, this would be the area for that probability. Okay, this is your A2 for A1. Okay, now let's take a look at the corresponding values of this one. So your probability of from 0.5 to Z to 1.80 would be equal to probability of X being going from 11 to 16.7. Okay, this is coming from the definition, and what you need to have is to calculate the areas A2 minus A1. Okay, now the question is, what is A2 and what is A? Okay, let's start with the A2, which is 1.8. What is 1.8 here? 1.8. This one is 0.4641. 0.4641. 0.4641 minus 5, right? Minus 0.5, which is this one. Okay, here I found you. It is 0.1915. 0.1915. 0.1915, and our result will be it's like 27% probability under this curve. Okay, or the 7.26% of the population is located right here. This is the probability of being within that range. Okay, that is all about the normal distribution. Of course, you need to make some practices on your own as well. Thank you for listening.